Okay, good. So looks like we can start. So in today's technical steering team meeting, we will be talking about various uses of Netconf and Yang models in the context of ONOS, both in its capacity for southbound interactions with the environment and the devices, as well as potential to use it as a mechanism to expose ONOS functionality to the north, so that external applications can consume ONOS services with defined and prescribed using Yang models. So we have a full room here in Menlo Park, including Larry is here, and as well as Peter Lee from ClearPath. And we're hoping that this will be a lively discussion regarding various aspects of Netconf and Yang. So just to set the context a little bit, and this for many of you is going to be a repetition, so I apologize in advance. But there's a couple of different ways we can think about using the Netconf and Yang. It's in the south and in the north. And just so that to be perfectly clear, at least from my personal standpoint, Yang is about interface definition for external interactions. Therefore, I'm very interested in discussing how to use it for external interactions. I'm not interested in talking about how it can be used internally. To me, that's completely besides the point, and I would prefer if we avoided rat holes going in that direction. That's my expectations. Now, of course, I expect that we will stray in that direction, but I just want to be completely upfront about that. So everybody has seen the warning signs. Okay. So in that context, I think I can probably just open up the floor, and I know Peter, you're here, so maybe I'm just gonna toss you to the wolves right away. Did you want to open up with any remarks or any sort of, at least what you're hoping to get out of this? And
yeah, absolutely. Well, first of all, thanks for inviting me to the meeting. I didn't realize I had such a big wide audience, but it's great to be here. So I've been working with the ONOS team for the past few weeks, getting involved with Tom, who's hoping to organize and connecting us together in terms of exploring in what ways we could introduce Yang as a common kind of modeling way of defining the data models, in particular to provide additional service-related abstractions that we could then provide on top of ONOS to then be able to provide additional capabilities. So you guys have the core that's able to describe a lot of the STM-related flows, a lot of the controller layer logic in terms of leveraging the core constructs to then provide higher order service mappings, a variety of different use cases that could involve, and how we may be able to use Yang to express those type of models. Given that there's already a lot of standards organization-based work using Yang to describe a lot of network entities and behaviors and services, and going a little bit higher up the stack, more layer 4 to 7 type of service descriptions. So that's where I got involved, given my current involvement was the OPNF organization, looking at more holistic network functions view around how we could enable capabilities and consuming things like this, the controller stack, but also things in the virtual infrastructure stack as well. So we've been, coordinated to meet. I've been here a few times, working with Patrick, who's co-leading the initiative around Yang enablement, and also working closely with Larry on the XOS aspects of how we could leverage Yang and adopt that for high-level modeling on things beyond just the network, but things also at the higher layer in terms of service composition and things like that. So the
go ahead.
Oh, okay. I know there's going to be a ton of questions there. So initially what we're looking at is several approaches, and we identified a common use case, at least that we could use on the network service modeling aspects. So we're currently exploring the L3 VPN service as an abstraction model that we could use, and see how we could leverage the current work that's going on in IETF related to how they've been describing the L3 service as a Yang-based model, which is really meant to be an abstraction layer. So it's kind of providing you a view of a global VPN-based policies and configurations, and also allowing you to have sites that you could define and be able to create topologies of a VPN layer topology, what kind of ways you would connect them, any-to-any, meaning like full mesh type configurations or hub and spoke configurations, one-to-one mappings, what kind of potential encryptions you might be able to configure to enable sites to connect, as well as different types of routing hooks that you might be able to put into that kind of configuration, so that you might be using BGP routes or static routes, et cetera, et cetera. So most of these modeling constructs are meant to be decoupled from the actual implemented specifics. So the whole abstraction idea is that you could have a common service abstraction that everybody agrees on, so that whoever wants to consume that service talks to that data model using those service abstractions, and then the details will be left to the freedom of the folks who are actually implementing the controller layer stacks to then perform the right mapping between that site construct and the configuration construct down to the specific details, their vendor product, and their software functions, and what are models or ways they might actually have expressed themselves to ensure that the right configuration goes to those guys, and then you're able to realize on what the abstraction is describing.
So it is congruent then, and so if you were to use this picture right here, so the layer 3 VPN, for example, would then be used in a context up at the north. And then if there's any clearly, for implementation purposes on the environment, there might be in play another set of Yang models, but there's a disconnect. There's sort of a dead region there. That's congruent with what you're, just to make sure with what you're saying. Okay.
So on the current approach that we're looking at, if you don't mind, if you could throw up a web URL.
Yes, I can.
And this one's slightly out of date, just based on the conversation I had with Patrick. But it's a good talking point.
Where am I going?
We can start. Yeah.
Which one am I going to?
It's the wiki ONOS.
It's the proposal. It's the ONOS
Okay.
new feature proposal. Feature proposals. There is the Yang ONOS something.
So it's a very quick one I put together, and it's going to change a little bit. And let's ignore the resource abstraction layer for now. So just looking at the overall construct, it's a way to introduce service abstraction capability as an app. External most likely, or internal, doesn't matter, but let's say even external. App running that is providing the northbound interface for somebody who wants to consume that service to use, but utilizing a service abstraction layer which is going to implement, let's say, an L3 VPN data model set. And there's some kind of logic that happens to provide the service to the actual resource, the model mapping, translation, transformation, whatever you want to call it, to then transact into the ONOS core so that it can then do the right device inventory discovery, understanding that this device is this vendor's solution, somehow understanding that in order to configure that service that's available on that endpoint device, this is how you need to configure it, and then be able to transact that through the ONOS stack to then have that.
Okay, but so what is the dash line?
Yeah, that one bothers me.
Yeah, that one, I put it that because I knew it was going to bother everybody.
Well, because that basically represents creating another authority over the devices, right? And then we get into this whole realm of having issues with the authority, especially if there's overlapping edicts or inconsistent edicts. So, yeah, okay, so that one's definitely going to be a problem. But
the interesting thing is it doesn't say it's a model transformation, right? So that sounds like code that would be written that's capable of understanding the models and translating them into the ONOS constructs that get. I don't know if it's quite coming in the right place, but so you described there needs to be some implementation that takes the model, understands what it's doing, and then finding the resources and the devices that are going to be capable of helping to realize that.
So there's two forms of transformation that needs to take place. One is ONOS provides the device, host, the link, the topology, the flows, those basic constructs, which is more at the layer 2 level type of modeling, but it's really just describing the relationship between things. It does not have constructs to describe that there is some encryption capability on this device or not, as far as I know.
Okay, so yeah, so what you're probably referring to is that if you look at our subsystems such as device host link and flows and stuff like that, they provide sort of fixed function services over the environment. And fixed function, what I mean is that the functionality is prescribed. We have a means of discovering devices, their ports, links, and programming their flow rules and things like that. But it's fixed in that function. We also have a device which is okay for this for fixed form of control. But we also provide the driver framework, which is intended to be used for this more open-ended type functionality for interacting with the environment according to its capabilities, but still through a layer of abstraction that hides the protocol in use or hides the specifics of device capabilities. And so there's a homogenization, and it's and that surface, that control surface or management configuration surface, whatever you want to call it, is still an abstraction. But it's faceted in a sense that it doesn't really dictate that certain fixed functions are available for all devices. And so it's more adaptable. It's more suited to tailor the kind of behaviors or interactions you're having with the environment to the types of the equipment, because you will be doing different operations, again, the broadband units versus ROADMs versus switches versus routers.
But those facets aren't exposed to the northbound API, are they? So if there is a encryption facet, going off your example,
yes,
that wouldn't necessarily be exposed via the northbound API.
No,
is that
so
accurate?
the driver abstractions themselves are part of the northbound API.
So I could create a handle to an encryption facet, for instance.
Exactly, that's the idea.
Yeah.
Yes. And so they're consumable. Now those device drivers, those behaviors are consumable both by applications as well as by other core services alike, or even providers too, right? So because the purpose of the driver framework is to provide device-specific code.
If we have a client outside of the controller that starts tweaking the facets, how is ONOS going to start keeping the model consistent around intents that have been programmed into it? Because now we're back to your other point, which was we have multiple authorities that are essentially mucking with devices, and they could be in conflict.
Yeah, but the split is much lower, and so that offers ability to intercede if needed. Because remember, for example, if you have providers that use the same engine as the so let's say you're manipulating devices through Netconf, whether the interaction comes in through a fixed function provider or it comes through a device driver, it's still going through the same engine, and still we have now a hook for a place where we can actually catch collisions rather than when it comes in completely from outside. So
we have a hook, those hooks have to bubble up back to like the intent engine, because someone could come through a facet and change something on a device which invalidates an intent.
True.
It's not just conflict at the device.
The problem still exists, but at least it occurs at the realm where we're in a position where we can do something about it. It's not completely out of our hands.
It's risky because it's almost breaking some
Sure.
abstraction.
So it's not.
So what?
Yeah.
I want to add a few more things. So regarding there's the YAN project. I was thinking a couple of things that need to be considered. Number one is the YAN YAN model itself, right? So what we need to use. Okay. The second one is the YAN tools. YAN tools, the YAN forges the tools to translate that model into the internal stuff is the second one. The third one is in the ONOS, so the where to handle this, how to handle that is the architecture stuff, right? You give the highlight in the very beginnings. Okay, now it's based on these ones. I want to add a few more things. The number one over here, the YAN forge. The YAN forge is the YAN tools. Basically, it's translate this the YAN models into kind of a code, Java code, okay, to facilitate the programmers, to make the programmer easier. So another thing I want to highlight this one is basically for this resource abstractions. Okay, the YAN forge controllers basically is a couple of the concerns from my side. is number one is you want to take care of this controller specific things, or you want to do common things. Okay. In this model here, I talk with the Peter. So something that I want to check added here is the resource abstraction layer. Basically it's a controller specific things. Okay. So personally, I was thinking they were should taken care into the ONOS by the ONOS applications. So the sometime back, we talk about this ones is YangForge and the applications and the ONOS. So there's something need to be implemented between the YangForge and the ONOS. The other one will do the resource abstractions and some things over there.
So
before abstracting device resources?
Can I rewind the discussion just to back some things where we can agree? So basically, we can just build up a common understanding of things, right? So first, let's settle Netconf, right? How Netconf is used. So Netconf is an RFC protocol. It's for setting, getting configurations and stuff. It has got a handful of messages, like a dozen different messages with standard envelopes. What we need in ONOS is to have a Netconf library that will be able to drive us, and a controller based on that library that will be able to manage the sessions and be able to conduct this protocol to and from the environment. So we need that. Yeah. We thought we had that with the contributions from the happiest minds, but it didn't quite turn out that way. So we'll have to rework that code in order to get into that point.
Yes.
But we need this, and at this level. There's no Yang, nothing. This is simply XML over SSH or TLS, nothing else, just for record. So everybody agrees, right?
Yeah.
Right?
Yes.
So clearly the payload of the XML inside the envelope is then what prescribes the model. And so one could, in theory, code the raw XML. Now, I'm not suggesting that we do that, but in theory, that is certainly possible to do that without any fuss. Now, of course, because the models are complex and hierarchical, and in order to get away from dealing with the pain of maintaining the models and understanding that in raw XML, this is where Yang comes in as a formal definition of what the structure of the configuration looks like, what the semantics are, and the Yang tools provide the ability to be able to transcribe that interface definition or that model definition into various ancillary artifacts, which can then be used for applications to program using rich data types and using a richer set of semantics rather than just flat XML. Yeah. Right? So we're on the same page, or did I misrepresent something?
I think the one thing I want to add here is for the multi vendors. So each one we need taking care the different vendors. They could have their own.
No, I completely understand. Yes. So that's a separate story. So in a capacity of the south, when we are looking southward, where ONOS is a consumer of the Yang models, right? We consume the Yang models from Juniper, Sienna, Huawei, whoever, and we use those to drive our interactions through the Netconf library and controller with the environment. And so we clearly will be using those, and that would be all within the confines of the device drivers. That's basically, or providers. That would be in the southern capacity. So that's when we're consuming those. And so definitely, if we use Yang, we need to have we need to figure out how we're going to use the Yang tools to be able to. But this would be mostly build time integration, where we use the Yang tools to generate the models, the model-based artifacts at build time, and then be able to load them into ONOS. Because somebody still has to write code on top of those artifacts.
I think we currently identified the two parts. The one is in the wikis what they call the static part. That can be generated by the offline compilations. But for another things is tied to the configurations. Every single time when the guys system admins were change the configurations, they were generated the dynamic things install. The other part is
So this is where we're providing sort of the dead end zone. The Yang basically stops here. So we're not providing Yang pass-through whatsoever. So you can see that in this diagram, right? We use it in the south, and that's completely insulated by the southbound core APIs. And whether the southbound core APIs are the providers or whether it's hidden by the drivers, it's still hidden. And there's another layer of abstraction, and this is a Java-based abstraction that is through which you would then interact with those models. The device layer models are not visible to the north at all.
So ONOS is not providing a Netconf server.
No. Well, so not in this capacity.
Right. It's not exposing Netconf up based on dynamic yang
For
from the
devices.
devices.
Not
Or I
for the
can toss
devices.
through it.
Yeah.
But if you but in a capacity where we expose services to the north, I think, let's say that there is an off-the-shelf standard and well-accepted series of models for configuring various aspects of network, whether it's a layer 3 VPN or some sort of other transport layer security or other stuff. They're well-accepted. There's applications, orchestration applications external already that know how to interact and drive these models to configure the environment according to the model specifications. Mm-hmm. In that context, it would be huge value for ONOS to be able to export and provide those services compliant with the semantics of the model and the form factor of the model.
Well,
right?
Would that be ONOS, or would that be an adaptation layer on top of ONOS?
Well, so there would be an ONOS-based solution. How it's implemented, whether it's an optional application that loads on there, right? Because remember, ONOS applications are part of ONOS, at least the ones that ONOS ships. They're just simply electable at runtime. That's all it is. So that's the only difference between the core and ONOS apps. And so most likely those things would be deployed as ONOS applications so that they can be subdued in environments where you don't need them and optionally loaded, or even dynamically loaded and upgraded at the environments where you need them. So it would be an on-platform capability. At least that's how I was envisioning it. That would then provide the ability to provide adequate external interfaces that are compliant with the model.
But semantically, whether it's running within the Carafe container or not, it's an app. It is really an adaptation layer.
It's a detail, yes.
It's an adaptation layer.
Yes, exactly. It's an adaptation layer, right? Precisely. But then the model is implemented using the northbound abstractions, whether they're the fixed function service interfaces or whether they're the more open-ended device layer interfaces. But it's the adapter layer would be leaning on those things. There's no straight shot through bypass through yang all things.
Yep.
That would defeat the purpose, right? That's mixing internal and external representation is fraught with issues, many issues, which we could probably burn a full day meeting on discussing.
Just wanted to throw a couple of comments on alignment. If you don't mind shifting that back there. So, since one of the key benefits of using Yang is also leveraging nice tooling that helps to easily use Yang for external representations. Mm-hmm. So YangForge is one of those examples where we have created an open source software that is able to consume Yang as an input and is able to auto-generate a runtime providing northbound interface. So I wanted to just focus on that element just a little bit. I know that most folks might be familiar with like ODL's main tools, which is more or less, they do have some runtime generation, but it's more or less a code generator. So to be used during build time, as you mentioned.
Yes.
So you feed that in, gives you some class constructs that you can program and fill in the details and get those implemented. YangForge actually doesn't work that way. YangForge is written in CoffeeScript, which actually compiles JavaScript. It's all interpreted. So everything is runtime compiled.
So it's Node.js?
It's running Node.js. So you essentially is able to feed a Yang schema model to it, and is able to then automatically create all the class constructs as anonymous classes with class extensions and all that stuff dynamically, and then is able to actualize it into a northbound interface. Right now it supports REST JSON, and it has the ability to use YAML-based function definitions, which it just loads in and attaches as behaviors into the actual runtime model on demand. So everything is just runtime. So meaning it's not really a build process tool, it's just just use and just feed into.
So just clarification. Yes. So you in YAML you provide essentially a mapping when you call this Yang RPC call this JavaScript.
Exactly.
So
Or
that's
if you
effectively
modify this part of the model, call this JavaScript.
Yes, exactly.
how you inject the semantics of your model.
Yeah.
Yeah.
So what
that's sort of the key.
what is the benefit in your mind of that versus? I mean, you're doing the same thing as static code generation
Yes.
or build-time code generation. So why is one better than the other? Other than okay, it's kind of cool, but what
It is cool.
Yeah.
So having that, the main reason that I constructed in this way is to provide runtime programmability of the environment. So basically, when you think about interactions and the benefits of using schema to exchange the schema formats and data models, is that you could infer a given endpoint and what it could communicate, how you could talk to it, and how you could interface to make configuration changes by informing what the schema that guy has, right? So from the caller's perspective, by knowing what the schema that guy has, and if you share the same interface generation logic, whether it be RESTconf or whatever else, that protocol transaction is abstracted away from you because you're just doing model-to-model changes.
Mm-hmm.
If there's a way in which the controller can then actually push and manage what kind of schema and versions and revisions and changes that a given endpoint has, and is able to attach different functional behaviors to deal with that particular model, then you have absolute programmability of a given endpoint. Meaning you could change what model is serving, what version upgrade it has, and what function it runs when you program it as you talk to it. So you could actually tell it, I need you to become and provide this schema and data models for me to interact with. And as I make and call you using those calls, then you're going to react accordingly to what I programmed you with. And another fashion is, ultimately we want to create a system where people who are not Yang aware, or even JavaScript rather aware, can actually make changes to the schemas without having to be able to write Yang code. So imagine if the endpoint that is serving up these models are fundamentally mutable, then you could create a web interface that's, again, running the same JavaScript code on the web browser, can provide you the model view of a given endpoint, and you could add a new property, change its types. They'll say, oh, my constraints, I got to make it more strict in this way, I'm going to add a new regular expression pattern, etc., and have that be applied to the endpoint as you make those changes. Fundamentally, it's really for rapid prototyping. So folks who are very standards and specifications centric can really work with something instead of depending on some development community to say, sorry guys, I just made a schema change, you're not going to like it, you got to go and change a bunch of code and redeploy build and do that to eliminate that.
So it sometimes sounds like you've created a Yang mux, where I can mux one Yang model than any other model with transform.
Yes.
And because it's JavaScript, you're saying it's implementing dynamically changeable,
Yes.
as opposed to waiting for something like ON Labs or ODL to work with their to make physical code changes. And you think the people, your consumers, are going to be more easily to modify this code versus coarse ONOS code.
Yes. It's trying to
So the problem is, I think if I have go straight, as you say, go right to the device from Yang Forge, it violates this abstraction layer that controllers are trying to provide, whether it's ONOS or ODL, because essentially you're writing a controller that has a network element view as opposed to a network view in some sense, where ODL and ONOS are trying to provide a controller which provides not only that element view, but also a network view.
Mm-hmm.
And so there's some conflict in goals there, which I think is going to cause trouble in terms of integration.
Yeah, no, you hit right on the point. That's why it started.
I was paying
And
attention.
first of all,
I'd go a bit further and say that it's not, their models aren't really compatible. You sort of have to either say you're going to allow an abstraction layer or say you're going to not have an abstraction layer.
Exactly.
So then the question is, does ONOS want to get rid of its abstraction layer or does it want to keep it, I guess is the question. And is Yang a good enough reason to get rid of ONOS?
Well, so hold on a second. So the thing is, my thought is this. The reason we have the abstraction layers in place is to be able to provide a layer of insulation for layers above. And if you expose, whether you expose a different API or whether you expose a different model, it's the same thing. It's you expose different semantics upwards, and then you have to have the applications to the upper layers worrying about the different semantics, when in fact those should be hidden by common abstraction. There should be one way to configure PoE. There should be one way to configure O3 VPN. There should be one way to configure whatnot, right? OpenFlow controllers. Now, of course, the reality is in devices use different protocols, use different semantics even within the bounds of the same protocol to be able to accomplish these things, which is why we have device drivers. We have device drivers even for OpenFlow itself, and we've seen the need for device driver from one OpenFlow 1.0 device to another 1.0 device, because they even do simple things like say hello differently. And so there's always going to be need for some sort of a buffer layer, at least hopefully as thin as possible, but that provides device-specific absorption. And so the reason for that abstraction is to insulate the upper layers. Without, hopefully the abstraction is structured in such a way that it doesn't rob the upper layers of flexibility to be able to do certain things, albeit in a standard manner, standard meaning according to the abstraction. So because if you just reveal, if you let basically it's a free for all, yeah, I can let the device expose its way of doing things, and you can turn every knob on the device, then your application immediately becomes tainted by the capabilities of that device, or has to be aware of it and start differentiating between am I dealing with device A or device B, and the war is lost.
So going down that path of today within ONOS, it has that abstraction there. I can still go to a device, CLI to a device,
yes,
and muck with it.
Yes, you can.
And ONOS either breaks,
yes, sure,
or deals with it.
Yes.
So at some level, there is the ability to touch a device directly, and the upper layer needs to understand that A, was the device touch and repush what I think should be there, or absorb that network-specific change. What happens today?
Well, so that all depends on what we're talking about. Like, for example, when it comes to flows, we can actually repair from that. But when it comes to some potentially, you go in and change the controllers, then we're kind of out of luck. So I don't think we'll solve the problem universally, because there'll always be a lower level that you can go and muck with the switch. You can always go and unplug the power physically. Just
but essentially is that same problem.
Yes, same problem. But at least we want to minimize the when it happens within a certain realm, like within the confines of ONOS, we want to at least do everything we can to sort of channel things through a same conduit or same channel, and hopefully have a place where we can catch these conflicting.
So we're essentially administratively solving the problem by saying if you're under ONOS control, only be under ONOS control.
Yes.
And if you go outside that control,
then
there be dragons.
Exactly. Yes. Yes. And so my thought was, I had a question to get back on track to the mForge stuff. So you allow specifying the RPCs. How is that? How is the model delivered versus how is the implementation delivered? Is it delivered all in line as part of the same model, or is there actually two parts?
There's two parts.
The model and then the
control file.
Okay. And the control part is what specifies the wiring, essentially.
Control file is the what defines the bindings
and that's specified how? That's specified in
YAML document.
Okay.
Has,
okay.
What's your name?
David.
It mentions just JavaScript string functions.
Okay. Great.
So mForge basically takes those and compiles those. You could write it in CoffeeScript JavaScript, compiles them natively in real time, and then binds the control file definition into the compiled form of the Yang schema.
Okay.
Plugs them together.
And it deals with data changes that way too. You essentially in YAML say if this structure changes, call this.
Yes.
Okay.
So you have some innate, handling behaviors on when save operation takes place. You could chain, multiple save operations. Everything's asynchronous I/O, so it just uses promises framework to change those events. So you could then take actions and reject all transactions, things like that. And so basically, upon a trigger, you could write whatever code you want to do whatever you want. You can make another REST call somewhere or whatever you want to do to then transact that.
But effectively, it's just another form of loading code dynamically in what runs inside the container.
Yeah, it really is.
Right. Right now, we presently accomplish that with OSGI, which clearly requires that there's a prior compilation step and assembly step.
It really gets rid of compilations.
Right. but this is yet another mechanism to essentially accomplish that. But to me, the key part is that it comes in two parts. The model doesn't get tainted with the implementation. Okay, so that's good. That's actually
completely separated.
Okay.
The same model could be used with different control files.
Yeah.
Completely different.
Okay, so the quick question also. So this is just purely just Yang model processing. There's really no implicit Netconf behaviors there.
Yeah, exactly. So basically, there's Yang schema compilations, and then ability to provide some initial config loads. So you could have a JSON file that says I'm going to populate that generating schema with some initial set of data, or YAML document, or you can embed that computer directly to a profile, and then ability to attach those behavioral hook points into, once it's compiled, I'm going to attach these functions to it.
Okay.
Yang Forge is also a runtime, meaning it's able to then take that and run with different types of feature modules, which then could take the models it knows about to dynamically create different interfaces on northbound as well as southbound. I don't do any southbound private, just northbound, right? So it's able to dynamically run an Express web server instance, attach the REST JSON interface generation logic, and it's able to internally introspect its internal state about what modules it has running, and then dynamically create a RESTful API interface on demand. So it's not generating RESTful API interface, it's interpreting the REST JSON interface based on the model structure it has, but traversing itself on demand to create the REST endpoints to say whether I could accept the post operation because it's a list, or it's an object I'm going to accept the put operation. So it handles all those REST JSON-based transactions. Likewise, we could create a RESTconf feature generator, which could then do the similar thing and just throw it up into a RESTconf standard spec-based way of creating the endpoints and things like that. But right now, inherently, it just deals with everything in JSON. It's JavaScript. And I personally don't like XML too much. But so for that reason, it's just sticking with just JSON-based transactions. But it could be easily augmented to generate an XML format of that same internal data structure, and could be used, talking about the southbound aspects, to be a provider of the Netconf XML document that you want to feed into a Netconf protocol interface to then do the southbound transaction. So under that implementation, you could technically have the device or the driver or the vendor just send you the Yang schema file. And then you import it and load it into Yang Forge. You'll just actualize that model right then and there, and your ONOS core subsystem could call that API interface. We could even create whatever other API interface you guys want to use other than just JSON. Okay. And then you can spit out the XML form of Netconf, and then have that be sent by the next.
So effectively, it's another. So as David said, it's an adaptation layer. So in the context of that, just to get back to the diagram, it seems to me that, at least in my view, the transformation, sure, that belongs up there. But any state tracking, especially when it comes to resource state tracking or resource abstractions, those really ought to be maintained by the core.
Yes.
Right? Because you're not going to have just that application be able to in custody of the resources which may be in use somewhere else or be accessed through other.
So I think in your last statement, Peter, right?
Yeah.
So we know. I think you almost flipped this diagram because I thought, if I understood correctly, you're looking for Netconf adaptation layer. You could essentially use Yang Forge as a Netconf adaptation layer at the southbound.
As well.
Is what I thought you said in that last comment. I don't know if that was everybody understood that or not.
Yeah, that's what I was saying.
Right. So you could say, look, if you want a Netconf, you could use this stuff down the southbound and provide it that way, and then ONOS would have talk a common abstraction, like it always has. And for your Netconf provider, you'd say, here, if you want this model, Yang Forge could go from a Yang schema down to a Netconf XML file with your protocol driver then talking Netconf down.
Sure. Which is why I was asking precisely just to figure out where we could this could come into play.
Yeah, so on your question about the resource abstraction there, this I put together yesterday before I was educated today by Patrick that you guys actually have a driver subsystem. And I was just going through your documentation. I didn't see anything really related to the driver subsystem, so I wasn't sure about.
Yeah, because we right now don't use it really pervasively for device configuration activities. We use it in the capacity of OpenFlow behavior to tailor behavior appropriately to specific device behaviors, as well as for pipeline drivers to be able to tailor it to specific table pipelines.
Yeah. So
And for the most part, that's it. But the plan is to use it for broader device configuration and orchestration activities.
okay, great. I'd love to learn more about it. So you kind of think about that dotted line, which seems to be bypassing a lot of stuff, to should really to talk to something like a driver layer.
Yes.
But that dotted line does exist for a reason, which is the service abstraction layer is really high level. So it doesn't really have anything about devices or links. I mean, you're not saying this site is this device ID. It doesn't what. So it's just describing a site about a customer. It has a location information and it will have some identifier, but there has to be some mapping logic to what's real in the network, state-wise. So the device, this is the device we have, et cetera, and that device might have some information about some location awareness so that we can then do some mapping to say this site abstraction configuration really belongs to that device. So that mapping logic needs to occur somewhere. So the idea behind the resource abstraction layer, it seems duplicative, but you can even think of it as a transient data model, meaning it's not meant to be authoritative in any way. It's meant to be a snapshot of what's real in the ONOS core, just so that we could do that right transformation logic. Because ultimately, what also happened is that layer could then query ONOS, using the REST API to find out about all the devices, so that it could do the mapping logic. But think about it doing just that and then storing a copy of it for its own internal calculation reasons. So it just
it's changed, right? You've got the network's changing it from under you. That dotted line, whether that's from your tool, from YangForge, or from anywhere that goes down to the device drivers, scares the heck out of me.
Sure.
I think if there's a capability that YangForge or Northbound client requires a model extension, rather than go to the drivers, it'd be much better to have it at the intent API and say, look, let's add the constraint that is required into that intent layer, that abstraction layer, so that we can almost continue to look at a network view and do that resolution and leave the driver API and the facets kind of the implementation of the intent.
Well, exactly, and the idea is the drivers are really when you only know you're dealing with a specific device. So for the most part, the idea is that you program against network-centric rather than device-centric behaviors. Ultimately, it has to boil down to device-centric, but it's best if applications do that up at the top layer.
Compiler, the intent compiler deals with that. It doesn't solve the problem I think Peter's trying to solve about how can I quickly modify code without having to go through a compile cycle.
Sure.
Because then it says if you need something in your abstraction layer, someone has to go add that to ONOS before you could take advantage of it.
Well, and again, I think here, I wouldn't get terribly wrapped around the axle about having to go through compile mode, because I mean, we're not going to put willy-nilly code on, even today, before you put new firmware on a network, make sure that you've tested it. And you and I had this discussion about dynamic Java code loading is questionable, right? So especially with the script stuff now, right? That even magnifies the problem. So I wouldn't necessarily. I mean, I see utility in it, especially for rapid prototyping and things like that. But I wouldn't necessarily get terribly hung up on that.
Yeah. So I mean, we don't necessarily need that at the core layer. The core layer should be the consistency layer. It should be the sanitizer. Well, it has to have. Right?
Yes, but okay, go ahead.
So fundamentally what is needed is that the service is describing configuration states that the core models don't have as properties right now. So if there's a way to attach a set of arbitrary attributes about a link. So I mean, think about L3DPN. You're really describing the nature of the link between those two locations. So let's say you have two device models, and say you create a link between those two using the core, and say you want to inform about additional attributes about that link. You can pass in information about use this encryption protocol, et cetera, whatever the VPN nature things is, encapsulation, et cetera. If somehow the service abstraction layer could then attach that in when it works with the ONOS core model and says, I'm going to create a link object, but here's a bunch of arbitrary attributes you may never have seen before. Can we still store that and have that be referenceable by the southbound device adapter layer, who's going to then look at it and say, okay, my link state changed about these two devices that I control, but I happen to know about those attributes, and I'm going to apply those as I understand it to enforce that service abstraction. I mean, would something like that be possible? Because I mean, ultimately, we don't necessarily want the service abstraction layer to have to figure out that I'm talking about this device vendor X that has these set of schema models and send configuration directives directly to it. I mean, it can, but that just is essentially doing that.
But I think what ONOS is trying to do is capture a core model that abstracts those things, and yet device specifics may implement them very differently, but they have to have in the core model a common abstraction so that they, when you operate at the model level, you operate at that level, and you not have each device do what they want, right? You don't want to pass these attributes blindly down to the device driver and not have ONOS know what's actually happening on a device at that point. I think you break something and all of a sudden ONOS doesn't have full control anymore because a given device driver, it's just passing these blindly through, and a given device driver could go off and whack the whole system. Now, it could happen anyway, to be honest.
I think some things you need to pass through the device drivers, like the network element properties or the IDs or some things. So back to the layer 3 pin case. I think that over here we just draw the one things is use the YAMForge to generate some frameworks over here. But we still some things for example the service logic is a miss here. So every single time when we get the topology, we need to read the layer 3 VPN application need to read the topology from ONOS. So that topology gives you the IDs blah blah, and you can use your layer 3 VPN network model to specify the VPN site. And based on those models, you can calculate the path, everything, right? And then you got the network element IDs. You can pass down that ones into the ONOS. So I think it's a way so the driver can use that the network element ID or the properties can identify which drivers or which the company's the vendor's driver should go. That is our the current the views how to link the service models, network models into the network device models.
Yeah. So I think what Patrick is describing is what I just talked about was just having some provisions where the core models fundamentally stay consistent in terms of what they deal with. Because if you start describing the higher level service related attributes and try to model all those as part of core, then you're trying to satisfy the world, right? Because everybody's going to want to, I want this attribute in there too, or et cetera, et cetera. But I definitely get the notion that okay, maybe it's not comfortable that some unknown blob of stuff is passing through the core just to be handled by the device after layer. So alternative approach would be to layer those driver subsystems to then say on a per service by service basis, create a new driver subsystem that is dealing with that service abstraction, because part define the service abstraction on service by service basis, that the controller app layer would then communicate towards, and then each vendor would then have to create their own driver-specific adaptation layer based on that service abstraction using the driver subsystem to then get their configurations. But under that case, the side effect also is that it's more or less bypassing the core. I mean, it's kind of parallel to the core layer.
Yeah.
Right?
So
still going through, so it's kind of still
right. The drivers could be said that they're bypassing the core. Yes, they're essentially direct channel to the southbound. However, it still goes through the important part here is it goes through the abstraction. And for the most part, drivers, you operate on drivers directly in a capacity of direct connection with the device already, direct or indirect, but it's still you having a conversation with the device one way or another, and it's from a single standpoint already. So it's already subject to the same philosophy as the providers. In a sense, the providers are operating in a local context only. They maintain very minimal state, usually just connection-oriented state, and there's no distribution behaviors or anything like that. Here, the primary value is the common abstraction and insulation from that. Now, the distributed part comes here in an aspect that that drivers are usually delivered as an application, therefore are available universally in all nodes, and you can conduct, provided you have the connection from that, or connectability from that node to the device, you can conduct that interaction from any node. So this gives you HA aspects in the sense that you can conduct the operation anywhere you are. One thing with the form factor, if I just can clarify a few things. So here, this is a little bit of a change of subject. Do you envision this? At least it seems like we talk both this outlined, the stuff outlined in blue or aqua color. Do you envision it running externally, or do you envision it running on platform, on ONOS platform?
I think more the latter, but it could be modeled externally. It just has a full
Okay, so if I may make a recommendation, I would definitely go for the latter, because if you're running it externally, then you have other things to worry about, like the HA aspects and stuff like that. So I would definitely recommend running it, at least initially, structure it as an on-platform ONOS application. That means you can run it anywhere, for right now.
Yeah, would have gone the other way.
Should do.
Well, the thing is, if you want it to be provided as a service that ONOS provides to the outside world, just run it on platform.
Yeah. I must say, actually, we talk about this once the purple ones is need to be implemented as the internal applications with running with the ONOS. It's we're on the same page.
Yeah. So no, I was talking about the whole outline.
The whole
So
block.
you're going to start a V8 engine within the Carafe container and code.
I don't know how to make that work together yet, but
Ryan, V8's faster, but I don't know. I haven't looked at the performance difference. Rhino actually handled multi-threader better than V8.
Whole block is costly.
Yeah, this is where I would have went more
Yeah,
microservice
a lot of
architecture type of thing. But
yes, I don't really know how it's going to happen yet, but that's why you guys
so
are here.
yeah, you can put it external, but then what you have to do is then your external interactions with the drivers or with the
you're going
services.
over REST.
You're going over REST, and it's not suited to the high-frequency
It
interactions.
depends on the frequency
low
you
latency.
actually interact.
Yeah.
I mean, there is an assumption that I always make that maybe it's a wrong assumption, that ONOS is providing enough basic constructs that you can model or decompose any higher level service into those constructs. And I think when you need to go around ONOS, it's saying ONOS isn't providing the right set of constructs. And that's, my assumption is it's providing enough constructs.
Well,
I guess the question is it? When you talk about, because you talk about
in general, I think the constructs to map things to network into a topology of relationships, you guys have the right constructs. But when you talk about services, service isn't really about network modeling. It's about service configuration modeling. So, when you want to define additional characteristics about a link, that you need to be encrypted. I mean, is that ONOS's response to even care to know that it's an encrypted tunnel, utilizing some kind of
So to that effect, we provide network configuration subsystem, which allows you to store essentially intent for entities which exist or might exist, but do not yet exist. So
I mean, there's fundamentally two parts, right? One is plumbing, like how do we get packets from one part of the network to another? And most of the abstractions and ONOS that we have today have focused on that. And I think David's point, I think we've sort of solved, or mostly solved that problem. The other part is how do you want to transform packets along the way?
Yes.
And the way that people classically think about transforming packets is in terms of boxes. Like I turn a switch on a box, or I put a box in place, or I add and remove these things. And like these, I think then this is sort of where NFV kind of comes in as well. But how we inject capabilities, or really from an applications perspective, like what requirements, what are the sort of transformation requirements that a packet goes through as it comes through the network, really need to be better described in ONOS. And that's where most of the sidestepping comes in. That's where a lot of the driver stuff comes in. And I think it's going to be, we have to sort of give a little bit on both sides. In ONOS, we're going to have to figure out, what are the right abstractions for things like encryption, compression, firewalling, those types of things. Do we need to put them in a container? Can they be run on device? With a new P4 type device, can we compile those behaviors into the device? Or if we have an NPU or an FPGA, can we put those on device? Does the device have capabilities that can be exposed? And then ultimately, it's a constraint problem at the policy layer. can I, given the capabilities that I have in the various parts of my network, satisfy the constraints of the application service request?
Yeah, I'd sort of echo that and say that OpenFlow, which has driven most of ONOS design, is pretty good about sort of providing control plane SDN where you're not munging packets. But whenever you have to do data plane SDN where you're munging packets in some way, OpenFlow doesn't have a lot to say about it, and that's where NFV does. But I think it's done in this really sort of complicated way that doesn't have a lot of good abstractions. And I think ONOS's job should be to provide good abstractions for all kinds of SDN, and I think it's something that will develop over time. And I agree that a lot of these things that seem like weird hacks and violations of the abstractions in ONOS are simply because we don't have good abstractions for data plane SDN. And it's a hard problem to solve, but once we solve the problem, then there will be a lot less talk about this sort of thing.
Mm-hmm. Yeah, definitely supportive of not thinking about things as devices. All for that. Coming so from an abstract modeling view, if you guys introduce the new entity model called transform that can be attached, retained together, describe a link from this direction to that direction. It's going to go through a series of transforms, and then on the other side, it's going to get retransformed this way. And there's a way to put that in. Hopefully, it's a perfect candidate to say from this flow as it starts, it's going to go and get transformed into this encrypted flow, and as part of the transform operations, these are the parametric comments. I mean, it's way we could express those things if those models did exist at the core to attach those behavioral things into those type of transactions.
And then the implementation may be you push the functionality out to the VM or the server that initiates the connection. You have a device that's capable of doing this in hardware, and you have Netconf or whatever protocol for configuring it, or you have some FPGA or NPU that you can push the function to and tell it to
They
perform.
could use their own built-in encryption processors to implement that flow transfer. No, it's up to the device to do it. But we shouldn't have to assume or know about the device capability when configuring. We should just inform that.
And this is how an SDN controller becomes an NFT orchestrator.
I've heard that.
I mean,
Sure.
Yeah.
That needs to be an explicit decision to make.
Yeah, exactly. And I'm not sure we necessarily want to do that immediately in ONOS. And that's why I think, what Thomas is saying, like, make this an app and just run make it an app on top of existing ONOS is a really good approach that doesn't really require any changes to ONOS. And I think experience in building that app, you'll get some ideas as to what the sort of data plane abstractions are that you might want to evolve on this.
Yeah, and so to an effect, you can achieve that if you do that dotted pipeline line, even though it's still, as David pointed out, it's still a little bit dangerous. But if you at least implement it using the driver abstractions, which an application can bring its own abstractions, right, into the game.
Yeah.
And supply. Of course, it's predicated on also having the implementations of those behaviors available for the devices. But I think that will at least provide the abstraction and sort of the point of decoupling from southbound for northbound.
Yeah, so that's what we're thinking right now, working together with Patrick. We wanted to minimize, at least for our initial approach, any things that might need to change about the core in their models and how that's transacted for this capability to be possibly realized. So just by having completely as an app, separately, just doing everything kind of on its own related to service abstractions, and then now that I know about the driver subsystem, we could have a driver subsystem component that's kind of mapped to the L3 VPN stuff. It doesn't have to be a perfect abstraction, but at least something there that could then be used as a vehicle to interface with the southbound transactions around at least the L3 VPN implementation, so they could then do whatever they do. And ideally, it's some kind of a schema model about that southbound device that could be transacted to Netconf. But if it's not, at least we could map an end-to-end flow. And to what extent we could utilize awareness of the core inventory of things, like devices, links. Maybe, this link doesn't exist, didn't exist before because it's, guess what, it's not there too. It's VPN stuff, it gets established on demand, so we could create that link record through interacting with the resource abstraction layer down into the core. So there's an interaction happening at the same time as some service getting realized end to end. At least for the first one in trying to introduce Yang. And then as we do that exercise, as right now mentioned, I think we'll learn a lot and see, how is driver subsystem really the right abstraction to push these things through for the southbound transaction? How scalable is it? Can we do that for every service? How flexible is it? To custom every time.
Yeah.
Maybe we want
To David's point, hopefully you can use as many of the network-centric or sort of device agnostic mechanisms to get certain environments set up. But if that fails, clearly when you need to have conversation with device-centric type interactions, then you would use the abstractions. But I would try to use as much of the, let's say, if the intents will do, then you should use intents.
Yeah, I need to learn more about the intents, especially if there's the ways of sending in additional parameters about that somehow can be translated into the device layer, into then pull and then do something.
And where the intents don't meet it, I think the conversation has to be as a time to extend the intents to meet it versus go directly to the device driver. Because to be going down the device, even exposing the device drivers up, it's going to put you in the same category as some other controllers that have a plethora of vendor-specific, essentially, models. And now you get incompatibilities.
And it just seems the wrong level of abstraction. Like most of the time, I don't want to talk to this SCSI or ATA or whatever driver. I'd rather talk to the file system.
Exactly.
And if you talk to the driver behind the back of the file system, it usually causes problems.
Sure, and which is why I think David was cringing earlier a couple of different times. But I think we need in order to be able to get the job done, we need to use whatever means available. And sometimes it may signal the fact that we don't have the right abstractions or high-level mechanisms in place, and that's great. Let's use it as a learning exercise and try to plug them up.
So Thomas, I know this is just one example, right?
Mm-hmm.
I mean, it could potentially come up with another half a dozen sample use cases that probably impacts different layers and also some VMs and all that. So I'm wondering whether we should at least try to come up with those half a dozen use cases and apply it to our abstraction models of ONOS to see if there is any changes required.
Well, my preference is to proceed with a sharp edge forward. So basically, you have narrow, very reasonably specific focus, is not to get distracted with, because if you have a sort of wide front, then you risk at getting distracted and slower progress. There's more drag. So now I prefer to just go with this specific model, try out the mechanics, and then broaden it. Exactly, and then you can iterate. And there could be necessarily.
No, I agree. I'm just, I can imagine that some of the services really impacts layer 4 to layer 7 and some layer 0. And
once you figure out how to use one, this is mostly here about the mechanics, right? The Yang is here about the mechanics of how do we work with Yang as a mechanism to specify the standard model of behavior, and whether we use it in the context of one model now, one specific model, just to make sure we focus on the important things, on the workings of this. Once we've worked that out, then applying it to 2 or 20 different models is just going to be, it should scale fairly well then. But if we start with 20, then we're going to repeat the same mistakes or missteps 20 different times, and it's going to be much slower progress. It's gonna dilute our focus, and so I would prefer not to do that.
That's what we can do. But I think immediately behind that, Thomas, we don't want to go Syrian approach to this.
No, we don't have to go Syrian, but use this as a scouting mission, and behind the scouts can come the whole army if that works out, right? But that kind of thing.
Yeah, assuming that works.
Assume it works, right? But if it doesn't, then we know. Then we have. If it doesn't, or if there's issues, then we don't have to.
We fail quickly.
Exactly. Exactly.
If you scroll down a little bit, there's also a to a demo application that I presented.
This one?
Yes. On Friday, it was a slightly limited audience. I just started my own personal repo in GitHub, where I just collected the IETF Yang schema models for the L3VPN, and it has 2 main dependencies, routing and interfaces model. And I wrote a simple control file, which is the L3VPN demo. And it doesn't really do a whole lot. You could click on it. So it's a typical format of a control YAML format. It's pulling in the Yang schema with the custom tag main Yang. Default configuration, main JSON, DAGs. Declare the dependency as another Yang schema, And then there's that save control logic for that
Yes.
module that's attached to that function. And right now, all it's doing is when save change happens, calculate differential.
And you wrote it in line too. That's interesting.
Yeah. So this is the basic semantics in which you could attach things. I just attached the save control logic, but you could actually rebind any arbitrary element within that entire tree. And sometimes you do that when you want to have some auto-computed behaviors. So it's not, it could actually override some default values, have a calculated default value. So there's a lot of stuff you could do, and I still need to document the whole lot in the YingForge, but there's a lot of flexibility there. But this is the basic control file that defines the application behavior. And so, you could run that now and give it the full REST API for working with and creating config file. Actually added some examples JSONs, you can actually do a curl request against the endpoint.
Now, given you know the target of the command as well, right? You know not just the model, but you know the device target at that level.
The device target? No.
You don't?
No, we don't. Because right now there is no.
Translation.
Yeah, I was just doing software.
It would be interesting if you say your save or your RPC mapping, if you could say, look, if I'm doing this operation and the device target is this type, here's the coffee code or here's the script. If it, you know what I mean? Because now I can have different scripts per type. Just off random thought, off topic.
Oh, you could actually do that. You could attach any arbitrary functions you want.
But I want to have a different. I want to have a different implementation based on the target.
Yeah, you could. The main trigger could call, do a batch.
I know. You could redirect later. I would say exactly. Put it in the YAML might be interesting. Have a kind of a map there. Say if it's this target, then do this. If it's this target, do this.
Interesting. Yeah, that's cool. Yeah, we could think about ways to augment that target's definition.
Yeah.
By annotating.
And that's where the target actually could be a selector.
Yeah.
Because you could do it based on tags or some sort of query. If it matches, then here's the code to write.
Interesting. Okay.
Sorry, off topic.
Yeah. I'd love more discussions on that. Okay. So this is an working example of a demo using IETF-based Yang schema. You just run one command, load it in. You have a runtime REST JSON interface. You could issue API calls. Comes to the standards, one service configuration and one site. You could add additional sites to it, change properties, and see the change behaviors happen. So that thing is there. Whether we want to use the IETF draft version as is or change it, that's
this is a separate story. It's a model.
It's a model.
The whole thing is pick one and go with it, right?
Yeah, and then the next question is, okay, how does that save function talk to ONOS?
That was actually my next question. So then, if you were to go back here, how do you envision that essentially we go from CoffeeScript to the existing Java APIs that ONOS provides? This is where I was hoping would be part of the sort of the integration. The framework for this.
I thought you could actually expose, at least in Rhino when I did work on it, you could expose Java functions into the JavaScript namespace.
Sure, yeah, so that's one thing, but then also OSGI brings picture into this, right? How do you do reference injection for the services?
Yeah.
Which we certainly have solved that problem for our REST APIs, for our CLIs, and various other things which are not loaded or components whose lifecycle is not managed by OSGI. There is a way to do that, where you basically provide a service lookup and you just retrieve references.
You could also argue that because it's being written in JavaScript or V8 or different library, it might make sense to learn this go REST, even if it's within the control.
Some other RPC. Well, have native, some drift or something.
What's sad is that then, this is not, all this is just an API, an RPC adaptation.
Exactly, yeah. And I prefer not to get.
It seems to. It's something that is of no interest at all to me, but I guess it's interesting to people if they've written applications that depend on IETF L3 VPN.
Sure. So where it could be interesting to a customer is YangForge could present a standard interface, and and it could essentially mux to ODL or ONOS based on the JavaScript you've linked it to. And so from a customer's perspective, I've got a high-level API that abstracts out the whole controller, and I'm now portability across.
So the question is how much code you end up writing in these CoffeeScript, right? If you write too much, it's still code.
I agree.
Yang is code, the YAML is
particularly
code,
if the two
XML is code,
models.
JSON is code. You should not dilute
I'm not, but again, it can be looked at as kind of providing
Sure.
Another idea would be to just implement the REST API natively which might be faster or might not. I don't know. I mean, it's possible Yang makes it easier to get this interfacing. But it seems very much like these other kind of interface generation tools that, you know, they give you the illusion of productivity, but at the end of the day, the semantics all has to be created somewhere.
Yeah, right. The coffee script.
Usually, yeah. Well, in ONOS, it usually means that you're going to have to write Java code.
Yep.
Because the semantics are going to be implemented in Java. And there's also this other layer of semantics, which is on the other side of the RPC interface, which is that the application that's calling whatever these RPC interfaces are, be they REST or whatever, has to have an understanding of the semantics. And where are those semantics defined? Well, I guess in this case they're in the IETF spec. But they're not in the Yang. I think that's a really critical piece of information.
Yes.
That they're in monkey language in the IETF spec. Basically, and they're in code in the application that calls the interface. And they're in code on the other side of the interface.
So the almost so one thing is added here. So the Fridays in the mornings of Fridays, lots of Friday. So the Janin also gave demos. Basically, that one is use the Yan tools from the ODR's open source, build add the ONOS specific things. Use that tools to generate the source code for the ONOS and add it into the into the ONOS path trees. So it's generally it's based on the IETF modeling and the Huawei's specific device model. And we already get to that stage model, Yan tools, source code mapping to the ONOS APIs, to the source northbound APIs. So the other ones is often known as we also see there's the Yan Forge demos. So the some overlap is over here. Eventually, I think we need to consolidate both by using the Yan tools or the Yan Forge to generate the code.
I mean, the question is, do you want Java or CoffeeScript? And I mean, there's a lot of fundamental differences here, right? There's advantages to both, and there's disadvantages to both. There's static checking versus no static checking. There's more runtime exceptions, but faster iteration, and maybe a more accessible programming language versus a heavier weight programming language that the rest of the controllers are in. So there are pros and cons to both of these approaches. Yeah, I don't think you have to pick one, right? Because your models are ultimately going to be the same, and you could write your implementation or your semantics in one language or the other. And it may make more sense if you have Java programmers and you're writing a driver to do the statically built Java classes that you basically build your driver against. And that may have better performance, better integration, and you're more confident that you're not going to run into runtime errors. Also, you don't have models that are changing dynamically. But maybe at the service level, where you have some customer who's going to be writing code, it's easier to teach him CoffeeScript and the ability for him to try out things quickly and not have to go through like a rebuild of the whole controller or a rebuild of an application and re-inject it may have some advantages.
I think when we talk about the service levels, so take a look. As I pointed out, the one thing we missed here is the service logic. That is basically tied to the service-specific service, like the L3 VPNs. So if you need the rigid topology based on your network model to figure out all those things, use the particular PCE the algorithms to calculate the path, everything, right?
No, I think
it's not just the copy.
The model defines the interface, and then you have to write implementation that
exactly
says what to do with that interface.
Yeah.
So you can do that in CoffeeScript here, or you could do it in Java using.
We basically focus on to develop the applications for the ONOS, right? So the Java code is, to me, is basically I focus on
there are a lot of advantages
for the
to Java in the ONOS ecosystem.
Yes,
for a lot of reasons.
it's pretty clear.
The other question I have about this, because you are creating business logic in CoffeeScript that influences the network, how do I get the full control path back to this business logic when the network changes, so that the business logic can address those changes, and whether, because essentially your L3 VPN service is an intent at some level, and so if that is no longer valid because some change on the network or failure on the network, that kind of needs to come back up to this logic to complete the control loop. And done anything with that so far, or thought about that, or?
Yeah, that's why I was entertaining, to go back to the diagram, having some kind of a synchronized resource model state being aware to the application, so that it's like I said, just transient objects that has some kind of loop logic between the ONOS core and itself. Maybe there's some ONOS notification systems to tap into, or it could just be careful, obviously, with downside that it's not going to be always consistent, but some way so that it could then locally make determinations about some main failure states. I mean, if all of a sudden that device that you built a tunnel between goes away as a record, then you know that something's broken about the service state. So there might be some ways we could kind of more localize the inform, but there has to be some kind of synchronization loop downline. Because it can't be a set it and forget it logic because you're delivering a service. You need to know something about it.
This really is an intent engine at some level.
Yeah.
That's what I think so.
Pardon?
You can build more of your intent logic and sort of policy logic and implementation into the CoffeeScript, or you can do just strict translations. You can say we're going to translate to like some small subset of high-level intent or network.
If the
policy.
if the Java intent engine has all the right abstractions, the CoffeeScript kind of tends I'm going to decompose it down to intents.
Yeah.
Or it's decomposing maybe into a small subset of them rather than trying to do complex.
But the intent engine itself, the compiler does that, right? Because it can have a higher level intent, and this is just another way to compile from higher level intents down to kind of that assembly language of the controller.
Yeah, I mean, I guess I was looking at it more. This CoffeeScript stuff provides really just quick jumps over to the Java code where the heavy lifting is done. Now, granted, yes, you can do
decomposition.
You can do JavaScript is actually more powerful than Java in terms of expressivity and everything, right? It's but generally in the context of this, I was not assuming that we would be doing heavy lifting in JavaScript.
Well, as you said at the beginning, there's some prototyping. It's very possible that there's a lot of my prototyping in this.
Absolutely.
And then at some point I say the performance isn't there, I need to create.
Or the HA is not aspects are not there, right? Exactly.
You don't want the flexibility of viewability.
Yeah, I'm in production now. Flexibility.
Exactly. Yeah. But I mean, at least you've gone through something that allows you to fail quickly, change things really quickly, and then once you're settled and you agree on the logic and things seem to make sense, then you have a choice. You just run with it or build it into the game. At least when you do that, you have a reference in which you already proved it out. So this becomes an implementation exercise.
It would seem like something that would be highly useful is some sort of native JavaScript APIs for some of the interfaces that we have, and whether that's through the JVM hosting JavaScript or through some RPC mechanism.
Yeah, I mean
that would help. I think someone who's writing the CoffeeScript have.
Yeah, if there's a way in which you could do more of a native interaction with interface, rather than you having to consume the published REST APIs and do transactions, maybe protocol buffers or something that could then interface changing abstractly. Information state between those two things. I mean, assuming that they're running on the same system. Right?
I think you do need the full control. But I keep coming back to where the use, other than the prototype, where is it useful in production? And I come back to it's useful as an extension mechanism in customer sites in production. So as long as we have the Java, the core constructs at the Java intent API, customers can take that and say, oh, look, you've got an L3 VPN and built it to the intent, but I want my customer L3 VPN, which is really just setting some hard-coded parameters on the default one, right? And something like this can provide that way to decompose that and build those very quickly without having to muck with the core code of ONOS.
You don't have to rebuild it.
And there I see it as very powerful.
Yeah, this is exactly what we were, Larry and I were discussing about how XOS can be the driving engine to then onboard these controller apps on per customer basis. So a customer could say, okay, I'm going to do a standard L3, I'm going to add some deviations to add more value to my service, do other things, and I just want to deploy that. But the underlying intent stuff that's in the core doesn't have to change because it's fundamentally doing a similar action, but it's something that's maybe fluid. Maybe they need to add some things into the model to make the user interface look more pretty. Whatever they want to do, they could muck with the schema, change it all they want, but we don't necessarily want to have to rebuild and recompile and blah, expose that abstraction. This is purely a transient, fluid stuff that's customer focused and centric, consumer driven, edge service abstractions. They could then just model and run as different controller apps. Deploy on purpose. Yeah, so that's kind of the gist of it.
All right. So I guess from my standpoint, I'm clearly interested for ONOS to be able to expose its functionality in the north, so that provides its services can be made consumable and exported in forms of a Yang model. How it gets done ultimately, I guess the things that are important to me would be to make sure that this is something that produces, it can be done with the least amount of code possible. It also plays nicely with the HA performance and scale model of the overall platform. And I think that basically would be it, I think. Because the least amount of code possible, code is liability in my view, and so the more you have it, the more it costs you to keep it. So, so whether it's something that would be based on Yang Forge or whether it would be something based on ODL tools, I mean, or I guess maybe we wouldn't know until we tried both. So
yeah, I think there's a place for both. Yeah, honestly.
So if you need to do both, then I don't think from own lab resources we can't afford to do both. But if it's something that our partners or collaborators are wanting to try both, it would be perfectly fine. Just pick one model so that we have some equal basis for comparison and try two different things. And also, it would be ideal if it could also, as David pointed out, not just with intents, but potentially with other frameworks, such as network configuration framework, to leverage as much of the existing service as possible as to house the meta information in ONOS, and because this way it can be distributed. Because if you don't, then in order to have HA, the application itself has to do it, or so there has to be yet another mechanism to distribute itself. And so, to that end, we already provide a number of subsystems that should help with that. So, also, I guess maybe another criteria would be how nicely it complements or interfaces or leverages the existing core infrastructure.
Yeah. So that's where I'm going to need customer help. Because I'm personally not that familiar with the ONOS system. I'm only a few weeks into it. I looked at your class documentations a little bit just to understand the basic organizations of things. But I don't really know all the semantics and facilities that are available. So either it has suggestions on, we could try this transaction layer or use this intent because framework has these type of information together. You're going to the distributor store, everything is going to work great. It's things that hopefully folks could share and kind of point in the right direction so we can start leveraging those.
All right. I think
one quick question.
Mm-hmm.
Can you go back to your slides?
Yes.
Some highlighted stuff. Very interesting. So here is the guidelines, right? It's from the Thomas point of view.
Well, I just want to make sure I'm not interested in turning ONOS core into an MD-SAL. There's certain reasons we decided where we didn't think that there was necessarily a good way to approach it. I mean, Madan can probably speak to that, or any review of our distributed or overview architecture slides will probably provide enough background information why we think that is a bad idea. Because
I understand about the core side. Our approach, basically, we're talking about is no changes on the current models. So the question to your slides here is, okay, it's the one thing. Okay, I saw that you're a good model.
Basically, we're talking about it's going to be code. It's going to have to be code, because the RPCs right there are the code, right? Whether it's CoffeeScript or Java code, it's something, and it would be delivered on top of ONOS.
So you cross the RESTconf in the North Core APIs?
What this means that we were not interested in providing as part of ONOS core itself, basically providing both a distributed core or dispatching mechanism, generic dispatching mechanism for just arbitrary models. Not interested in that.
So the intent API is part of the ONOS core you referenced here. Intent API.
So
Where would you put the intent API? In this
yeah,
diagram?
so the intent API, well, end API is right here.
Where?
That's
In
the
the
northbound API, right? That's
Okay,
so
the
you would be consuming. Maybe I'm missing a question, Patrick.
the question, yeah. So
This
you
is-
see
this
the
is where
intent
this
is
is-
here.
So the intent API is part of the northbound core APIs of ONOS.
Yeah, that means the basically it's no RefConf modeling for that one. Right?
Correct. It is exposed just as a REST interface.
It's just a
So
resolution.
I think we talked about. One of the things we sort of bantered earlier in these talks was maybe we should provide models for some of the constructs that ONOS provides today natively, either via Java API or via REST API.
Yeah.
Yes, we could do that, but what's the value in that?
Yeah.
To me, the value is taking off-the-shelf industry-accepted model
Mhm.
and allowing clients to interact with ONOS behaviors using that model. That's to me, that's a value. Now, if we decide that, let's say, intents are worthy of creating a standard for, working through cooperation with IETF or ONF or whoever's pushing that initiative, right? Then yes, but until then, I would say no.
Yeah. I think the value regarding this values. So the current ONOS is already provided the models, right? So we just use the Yan to represent that model.
Patrick,
And that one.
Yeah, that's my question. Why?
Yeah, it's a.
So if someone wrote, if someone
Now I try to see.
No, but the thing is, like if you can give us a good reason why, then we'll entertain the idea. If it's just for the sake of doing modeling because we like modeling, and that's like we have the guy we hired and he just writes models all day, like we're not interested.
Okay.
but
Okay.
you could take the model that ONOS now uses,
Yeah,
create a Yang for it,
sure.
put that into YangForge,
Yep.
have YangForge publish a RESTconf API for that model,
Sure.
and then the coffee script would do a very simple transformation.
Right.
Yes.
And all of a sudden you'd have a RESTconf interface
Yep.
for your models.
Sure.
Yes.
And the translation.
The value is a different argument.
Yes.
But you could
No.
do it.
So I understand that we
Yeah.
could. I understand that we could, and it is a possibility.
Someone
My question is, what's the value?
Someone
And I
might.
think that's the same.
But the thing is, like, what that does is, okay, I understand, like, what Thomas just said, where you have industry standard or de facto standardized models for certain types of behaviors, yes, it makes sense to have a well-prescribed, well-defined model for it. But in the case of something, a lot of the ONOS APIs, there still is some fluidity and flexibility.
Mhm.
And I think both Thomas and I would agree that it makes more sense for people to be writing against the thing that's actually going to be running in production, which is the Java class or the Java interface. And as these things get standardized, either officially or in de facto manners, then writing models might start to make sense in certain contexts. It seems premature at this point, unless there is a compelling reason to do so now.
Flip side of that, what's the downside of doing this?
The downside is that you now have a model that's going to be outdated as the interfaces get updated.
But you could actually use a Swagger API on top of ONOS to generate the Yang dynamically as it changes as you connect to it, to automatically feed into
Sure.
YangForge to get all the data.
Yeah.
Again, value aside, you could do it.
Yeah.
Issue with Yang if they know it.
But actually, it's take a look at the API change. If go to the API change, basically the modeling is better than the current the API. Just every single time the people in the application will call the other ones, right? So every single time when the API changes, you need to modify all those code one by one. But for the modelings, if the modeling change, you change your APIs, you recompile it.
So Patrick,
It's
regardless of whether there's value in it or not, if somebody wants to do that, great. We're not stopping them. That's actually fine. That's no problem. The thing is, it would be delivered just like that. It would still be delivered here.
as an app.
The other issue is it's
Yeah,
not a
yeah,
standard
yeah.
model, so
Yeah.
it doesn't actually provide a northbound client any value.
Exactly.
Because you still have to know the ONOS specific
That's
model.
our point.
Thomas, I agree with this one. If we go add the models, basically it should go to the apps. Yes, I agree with this.
And if you're going to generate the models, do it automatically, or as automatically as possible, because I think it's going to be a waste of someone's time to sit there and do it by hand. But if you
What do
want
you
to
mean to generate automatically? You need to build the tools to generate, right?
Yeah.
So you can't code it, or is it just?
You can't generate it automatically.
there are aspects that are growing, and there are also some small changes that happen.
And it's also
Yeah.
not guaranteed that you can actually represent the model of the APIs and ONOS in Yang, because Yang has some limitations, particularly around recursion and nested structures.
So this is how I would like to see it. So basically, there's the distributed core and its API have no
Models built on top of it. Yeah. So all the proposals here is no changes, no Yangs aware by the core.
Yeah, so the core and its API is completely Yang free, just like it's OpenFlow free, just like it's OVSDB free, everything, right? As a matter of fact, it's Raft free as well, you know, and yeah. The technology.
We're on the same page.
Okay, yeah, the topologies are nicely encapsulated. Yeah. All right.
The core need to be lightweight, the compact, and high efficient. Okay, to support the HA's scalability, okay, performance. We're completely on the same page.
Okay, great. So I presume then you said you were going to try to take it forward with the Yang Forge and try to.
Yeah, I mean,
would you be working with Patrick or how is that?
Patrick, working with Larry. I could use some support from the ONOS team to point. So I more or less at this point kind of wrote what I can. I think.
Okay.
I just want to know how we should best transact southbound into the ONOS. You know, whether I should use the REST API interface or something better I could use. We still have the question about how to pass the context down. So if we could capture it from an intent expression basis, then that'd be great. Anything else I could utilize, I could be pointing in the right direction.
Yeah. So we'll have to figure out how to do that because this is sort of strapped resource-wise from both code reviews and other deliverables towards our core use case. So that may be a little bit of a challenge, but hopefully the community will be able to provide. I mean, certainly use the mailing list.
Which one?
ONOS, well, probably
ONOS
ONOS
Dev.
Dev would probably be best.
But you guys
Okay, I'll
just
start
don't
posting
listen to
some
Slack
questions.
enough.
Yeah, no, still, it'll happen. I would still continue using Slack, but the mailing list, use mailing list as well,
Sure.
and that will allow the broad community to provide assistance.
Yeah, so at this point, we'll just kind of encapsulate, the models and things we've discussed, agreed, the points, this is how we should consider doing it. Encapsulate the project plan. I'll start interacting with everyone on the mailing list. But probably more of the substantial work will happen like in the second week of November. I'm just really tied up right now, starting for the OpenNet Summit, which is the second week of November. Which is happening in Burlington.
Yeah.
Yeah, so anybody, if you guys want to come, please come stop by. Yeah, but I have a project I'm meeting there. We're doing some big presentations. So I'll be probably tied up on that for the next couple of weeks. But I'll try to do what I can in terms of progressing that. I mean, the beauty of Yang Forge is that that whole thing just copy Yang schema files and run it. It's really not a whole lot of work. But it's really the control.
Well, so you'll have to figure out the mechanics of integrating.
Yeah, figure out the mechanics, how do we best communicate it, and if there's better ways we could interact, assuming that it's running the same system that we could tap into, then that'll be.
So you either figure out how to run it on the same system and deal with all of the issues, right? Or you'll figure out how to run it externally, but then you'll have to then figure out how to use either REST API or some other call mechanism.
Yeah, like ideally some kind of internal mechanism that gives us a bit more richer interaction dynamic.
And so, Patrick, I assume that you guys are proceeding still on use of ODL tools as well, too, just in parallel, or?
I think the current plan is this. Basically, we're not just work with the Yan tools. If the Yan Forge can help us to do the same functions, yes, fine.
Then you switch over.
We just started socializing the
Okay.
Yeah, I think the owner side should have common tools and the common tools and the common approach to support this modeling, right? So to us, it's first in phase one we just use the layer 3 baked-in as a simple case. And to demonstrate how to support this. And
I would use the same model, so that way there's an equal basis for comparison.
Yes. So the IETF modeling is the one thing. So for the device side, we are currently use the Huawei's the device modeling. I already uploaded that one into the wikis. For the layer 3 pin, go to the IETF. It's no problem.
Yeah, we'll look at the
So all these are.
There's a lot of work they've already done already in terms of connecting the dots that I just don't know about.
Our guys is developers over there.
Yeah,
he's thinking.
He's the one who told me about the driver senses. Oh, that's right. So we'll definitely collaborate on this. And
is it politically correct to say you're using ODL? It is not really ODL. They took some.
No. Yang tools is not ODL.
Yeah. So they mapped it to some of their own internally. What you're doing is the same code, open source, off the shelf, and you're mapping it to ONOS.
But Yang tools today.
But
Yang tools today generates Java that's specific to ODL. Sure. So you'd have to muck with the Java.
So we're doing the same thing with ONOS.
Yeah, we're doing the same thing.
If you're using Yang tools, you have to write a new generator that talks.
So the compilers is Yang tools, but we build the something for the ONOS.
That's reasonable. I mean, the app in ONOS model.
I think the discussion is beginning to get fractured, so I'm going to stop the recording. Thanks everybody for lively discussion. It was really useful. Thank you. Until next week.
Any tenant that wants it.